My name is Matt Hanson. I work at Element 84, and maybe a little bit of a warning here is that I've given a talk on Intro to STAC so many times. Since the beginning of STAC, and I threw out most of my old slides because as I look through them, I've used some of them again, but as I look through them, I'm like, this doesn't seem very useful anymore. It was a lot of old stuff. It was a lot of like why STAC is useful. And I felt like what it was really missing is what are really the key things that you should know as a user or as a provider. And so I did reuse some of the slides, but I kind of took a fresh look at how to organize this and how to present this information so that you could kind of come away with like what are the key takeaways. So this isn't going to be comprehensive. It's not going to go into like really nitty-gritty details about things, but instead kind of top level of like what are the important things so that you can go and learn more on your own. All right, so what is STAC first of all? STAC is really two different specifications. We've got the STAC spec, which is a metadata language that describes geospatial data. This is in JSON, and there's extensions that can go off of it. And then there's the STAC API spec, which is searching and accessing that metadata through an API. So when we talk about STAC, we're really talking about these two different specifications. Both of them can have extensions on it, but the core spec in both cases tend to be fairly simple. I think there's important distinction to make between static catalogs and what we call dynamic catalogs, because I get this question a lot where people are confused about this difference. So here we're looking at a static catalog. What we mean by a static catalog is these are static files on disk or on blob storage. You have a catalog, which is a JSON file. This is the root catalog, and it contains links potentially to other, what we call subcatalogs. Any other catalog within this structure we call a subcatalog. And that's for partitioning collections and items in different ways. Like we might have a bunch of different modus collections, and so we put those under a subcatalog called modus collections, and then all the collections appear under there. Or we might want to divide and partition our items up by year. We could do that. But all of these entities are linked together, and so the entire catalog can be crawled from the root catalog down to the ultimate useful atomic unit, which is an item. We call that sometimes a scene or a granule, depending on what your background is. And then those have individual data files, which we call assets. But this is really the static catalog structure. Things are linked. You can crawl them. This is a really important feature of STAC, at least as it was originally envisioned, was the ability to crawl, because that's how the internet works, for being able to crawl and index information. A dynamic catalog, or an API, is a little different because there's no such thing as subcatalogs. There's no reason to have subcatalogs because you can search this data in an API however you want, and so you can really partition it dynamically any way you want. And so this gets a lot of people early on, is that they don't understand this concept of subcatalogs. So when you're looking at a STAC API, which is the vast majority of use cases, most people really aren't working with static catalogs. They're working with APIs, and they're consuming data from APIs. You have the root catalog, which is the API landing page. And then underneath that, you have a bunch of collections. And then those collections have items, and then you have assets, like this. And so I've grayed out the catalogs, because in this case, if this was a static catalog, I might have partitioned these items in one way, and over there I might have grouped those collections together into like a subcatalog. But an API, I don't have that concept. So that's the first thing really to understand about this difference between static catalogs and dynamic catalogs. The key points I want to bring up about STAC are that it's built on standards, it's built on JSON, it's built on GeoJSON, it's built on top of the OGC APIs. If you're not familiar with the modern OGC API building blocks. They use these things called conformance classes, which really advertise capabilities. You don't need to understand all the details here, but the point is that STAC is built on top of these things. And not only that, a STAC API is a valid OGC features API as well. And so building on top of standards makes it really useful because you can leverage existing tooling. So like responses that come from STAC APIs that are in GeoJSON, you can immediately view those in like in GIS software. It's a really simple and stable core structure. So if you look at the core STAC spec, it's really simple. There's not a whole lot of extraneous fields in there, and that's by design because we didn't want things to change rapidly over time. We wanted to release a version and have it be the version for, well, ideally forever. That hasn't been the case. We released a version 1, now there's 1.1, but it's been quite some time. So that's a really simple structure to be as stable as possible. But it can be extended as well. In STAC, the metadata is decoupled from the data. This is really important too. Oftentimes with legacy formats, the metadata is embedded in the data files. In fact, most files, you can embed the metadata in the files. But that's problematic because you have to access this potentially heavy file that might be in cloud storage in order to pull the metadata from it. So there's lots of overhead involved. So it's a really powerful thing to have the metadata completely decoupled that points to the data, but the data could in fact be somewhere else entirely. And then lastly is that it's supported by an open source ecosystem. So, you know, the goal with STAC wasn't just to create a spec and then tell people to use it. It was to create a spec and create an ecosystem of useful tooling and data and make data available, especially public data available, so that people could really understand the value of it and that would drive adoption and that people could use this open source ecosystem to build their own tooling and leverage existing data on top of that. Okay, so now I'm going to go into STAC for users. So if you're a provider, you kind of need to know this as well, but like real basic, like what should you really know as a user? First off, let's look at an item. I'm not going to talk about catalogs and collections because they're really not important. The main atomic unit for you as a user is an item. This is what you're going to consume. Catalogs and collections are really just for grouping items into containers. So an item is a GeoJSON. There's GeoJSON fields, like those just come out of the box. That's what you have. And the additional fields that STAC adds are what you see here. There's a STAC version, there's links, there's assets, there's STAC extensions maybe, and then a collection name if it's part of a collection. Here's an example over on the right-hand side. And here you see the type. It says feature, that's a GeoJSON thing. You see the geometry, that's GeoJSON. I've collapsed the links assets. We'll get to that in a bit. But we have the ID. Like these are all really just GeoJSON fields. The only thing that you see that isn't collapsed here, that isn't GeoJSON, is the STAC version and the collection that this one belongs to. This is an example of this is a Sentinel-2 item, which I use for the rest of the examples here. The link structure, so this is the links for that item. You'll see a lot of the same types of links here, no matter what you're looking at, no matter what data you're looking at in STAC. You're going to see a self link, you'll see a parent link, you'll see a collection link if it's in a collection, which if it's an API, it'll always be in a collection, and then a root link. You'll always have these. We call these hierarchical links. And these are used to traverse the catalog. So a self link that's self-explanatory. The parent is always going to be one level up. So an item, its parent will be a collection. A collection's parent will be the root catalog in an API. There's a little bit more structure there if you have these subcatalogs. But in an API, it's a little bit more simple because you don't have that many levels. You'll see there's two other links here. There's a canonical link and a via link, and these are more like best practices that we do. The canonical link here is when we have an API, we don't actually treat that as the golden copy of that metadata. You treat that as an index, but the actual original copy of that metadata is alongside the data in blob storage. And so when we say canonical, this means this is the same metadata record, but it's in blob storage because that's super reliable, it's redundant, and we're not relying on a service to provide this authoritative copy of the metadata. So we have our bucket, and it's got all our metadata in it. If anything happens to our index, we could re-index that pretty easily. So that's what we use canonical for. And via this here, these are what we call relational types. Via just means that this stack metadata was created from this metadata.xml file, which is the metadata for Sentinel-2 that comes from ESA. So, but these are what you'll see in the Sentinel-2 archive, in the Sentinel-2 API that we have in Earthsearch. But there could actually be a bunch of different links. We encourage judicious use of links. You could link out to documentation. You could link to software. You could really link to whatever you want in your STAC API. But you'll always have these hierarchical links at least. Okay, expanding on the item properties. Item properties, we've got really pretty basic properties here. This is where your date time goes. You have some other date timestamps, platform constellation. These are your basic properties. It's like, what's the platform? What's the constellation? And then assets, if we look at that, I have an example of two different assets here. You'll see there's a bunch of different metadata. Most importantly, there's an href. This is the URL to where the data is located. But we also have a type of the data. In this case, it's cloud optimized GeoTIFF. And we have other miscellaneous data. We've got title, name, no data. Roles is fairly important. If you look at the STAC documentation, you'll see that there are roles for assets, because assets don't necessarily need to be just data. You could have an original metadata asset, and it will have a role of metadata. I don't have an example here of that. In this case, we have just two data assets, but assets really could be anything that's a file. So you might have a mix of data assets and metadata assets. So in this way, you can think of STAC as sort of a clearinghouse for all of the things associated with this granule, with this scene, including all of the metadata or a thumbnail or a visualization as well. Those are all assets. There's a new thing in STAC 1.1 called bands. So if we look back here, in this case we have a red band and we have a green band. Each band is its own data file. But sometimes you might have a file that actually contains multiple bands. And you need to specify metadata per band as well. We went back and forth on the name of what that should be called. You could think of them also as like variables, but in the end they're called bands. But they're really, you can think of them as like discrete variables that are contained within the same file. And so we introduced this bands construct here, where this is a asset. It's called this is a visual asset. So it's containing 3 different bands. And so we have this bands array that now you're seeing it describe metadata per band. So it has name. See how it has name there? And here we have name here. So you can see name can be defined at this asset level, or it can be defined at this band level to describe the 3 different bands within this single asset. Okay, so now what about extensions? As a user, what extensions do you need to be concerned about? Well, the ones that you should know about are whichever ones are in the data that you're using. So in the item, you'll see there's a STAC extensions list. And in this case of Sentinel-2, there's a whole bunch of different extensions. And there's an EO extension, file extension, grid extension, like there's a bunch of extensions. And some of these might be really useful for you as a user because they add various fields that you can search on in the data when you're looking for it. So in this case, I've expanded out the full list of properties here beyond these basic ones. And you'll see this uses a, oh, I actually covered that up, but let me actually delete that. Boom, there we go. Okay, so you see there's the EO extension, see has a prefix of EO, projection extension has a prefix of proj, and so on. So you can kind of tell which fields belong to which extension. And these are all different fields that you can search on when you're looking for data. Some of them obviously seem like they probably wouldn't be things you would search on. Like you might not really search on EPSG code, but you might search on view angle or off nadir angle. You might search on that. You might want things that are less than 10 degrees, off nadir angle, for instance. But if it's in the list of extensions, these are things that you should probably take a look at and see what's contained within these items. The common metadata. So I'm going to quickly just take a, okay. So this is a link to one of the files in the STAC spec repo, common metadata. So I showed some common metadata, but if you go down here, you'll see there's title, there's description, keywords, right? We have different date time fields like created, updated. We have licensing info, provider info, instrument, and so on. These are what are called common metadata. Now, the point I want to get across here is that you saw that name was defined at the asset level, but it could also be defined at that band level, but it can also be defined at the item level. So you can think of this common metadata as one single common metadata model where any STAC field that can be a property can be defined at any one of these levels. It can be defined at the item level under item properties if it applies to the entire item. If it applies to only one asset of several assets, you can define it at the asset level. If it only applies to a band within the asset, you define it at the asset level. So in this way, when you look at extensions and you see there's a bunch of fields, they don't necessarily only apply to one thing. They can apply at any of these levels. Now, some of them it doesn't make sense, and I think that will become immediately apparent as you look at it, that like it doesn't make sense for certain fields to be described at like a band level, but it is actually valid to be able to do that. Okay, let's go back here. All right, okay, so as a user, what software should I use? This is going to be really simple. I think as a starting point, use PyStack client and ODC stack. Like these are the two main pieces of software that I think as a beginner to stack that you can worry about. PyStack client is for searching APIs and getting items back that you're interested in. And then with ODC stack, you can load these into an X array, and now you can use the Python data system ecosystem to do things with that. And there's a whole workshop on that tomorrow. Alex Leith and Jarrett, my colleague Jarrett Kiefer, will be giving. So you can go to that and learn more about that. But this is a good starting point, and there's a lot of tutorials about how to use this. But there's a whole GitHub repository called StackUtils, of which there are a whole bunch of different tools. And as you get more into it, you could start looking through some of this other software and see what might be useful for you. Okay, Stack for providers. First off, I want to point out the STAC best practices here because most people don't read this. So if you are going to create STAC metadata, the first thing to do is read this document. It'll give you some guidelines for like how to name things, like naming conventions for things, like should you be doing lowercase, uppercase, like that sort of thing. They're best practices. It doesn't mean that they're required, but it's a good thing to adhere to if you can. And it doesn't always make sense to do so, but take a look at it. Next thing, how should I organize my collections? This is always a big point of discussion when people are looking to create STAC catalogs. and it's really worth some thought here, rather than just kind of going to the default or automatically just thinking you know how that things should be organized. Consider how the data is going to be used by the user. Like the user is going to be interested in a collection. So don't try and put too much in there, like data, like mixing data where a user is really only interested in a part of it. Like for instance, you wouldn't put like level 1 and level 2 data of something in the same collection. You could do that, and you could have a field that has the processing level. You can do that. Like that's allowable, but it's not a great idea because that's not really how the user is going to be doing that. They're always going to have to filter now on this processing level in order to get to the data that they really want. The next thing is this misspelled uniform. It's actually supposed to be uniform. Sorry for the misspelling. It's embarrassing. A collection, when you look at the items within a collection, they should really have uniform assets. And what I mean by that is this, what you're seeing here is this is an item assets field. Item assets are defined at the collection level. And they're not required, but it allows a user to look at a collection and see what assets are expected in an item when they go and fetch and look at any item within that collection. You don't have to do this, right? Like you could create a collection where every item in it has different assets and different keys for assets, but I don't think that makes it very useful. I think that having a user know what the asset keys and have them be uniform across every item in a collection is actually really important. Again, it's not a requirement in STAC, but it's a good idea. What extensions should I use? Well, I've put together this sort of best practices that doesn't only include just the extensions to use, but sometimes some of the extensions have a lot of fields that I personally don't think are really all that useful. For instance, the projection extension, you can define the footprint in native coordinates. I don't think that's a useful thing. Personally, you might actually have a case where that is useful, and that's okay. And so I put together this table of guidelines of when you're making an item, these are the extensions to use, and these are the fields that you should include from those extensions at the item level. You'll notice that, well, I guess, oh, I don't have the next one, but okay. So some of these extensions will have additional fields that you define at the asset level, but these are the ones to define at the item level. All right, what software should I use if I am standing up my own catalog? Well, first question some people ask is what API server should I use? Like there's a couple different ones and they don't know which one to use. There's STAC API, it has a bunch of different backends. There's STAC Server, and there's PyGeo API. I have a question mark there because I actually don't quite know what the status of that is right now. PyGeo API implements a lot of the different OGC APIs, and it does have a STAC implementation. My sense, if I had to guess right now, is that it's not, I'm going to say unequivocally, it's not as feature-rich as these other two. So as a provider, you should really take a look at these first two. I would say that probably most of the support and most of the time and developer time is spent on STAC API. It's what is used by Microsoft's Planetary Computer. They put a lot of resources into that, and it's really come a long way and has multiple backends, and that's probably what you should use, what you should look at first. It's using not by default, but the main backend is a Postgres backend. At E84 for a lot of things, including Earth Search, we use STAC Server. It's a node. It's a node-based server, and it uses Elasticsearch or AWS's OpenSearch as the backend. And we only use it for the simple reason that Elasticsearch is just super awesome at doing spatial aggregations. And we like doing spatial aggregations and being able to look at where data is at a high level. And then the next thing is, should I use STAC tools? As you're creating STAC metadata, you might come across this thing called STAC tools. There's all these different packages of STAC tools for Landsat and for Sentinel-2 and for all these different things that were used for Planetary Computer and for other reasons. And the answer is no. Don't use STAC tools. They're great examples of how STAC items can be constructed for various data sets, and a lot of work was put into them, but it kind of has grown to kind of a messy thing that has a lot of dependencies, and it's unmaintained. And so you're best off kind of just going back to like using PyStack or RioStack to create base items, and not look at stack tools, even though you might come across lots of information that says use stack tools to create it. That's a bit outdated information. Lastly, I want to talk just a little bit about stack workflows, which I always include in my talks because I think this is one of the coolest things I think about Stack, and I've been trying to encourage this for a few years now, and I think it's kind of caught on. Stack isn't just for consuming data. It's not just for finding data and using it. It can also be used as the central messaging between steps in workflows. And what I mean by that is this may or may not be a screenshot of a working directory of a scientist I might have worked with. It's nonsensical, right? It's like something was published. You all know. You snickered because you know that this is real. It's a mess. You don't really know what the final version is, and is it the final version class? Or is it final version? It's final version final because it has the word final in it twice. And you see what happens here is people will create these files and they're running it through some sort of process, and then they attempt to use the file name as a way to store metadata, is essentially what they're doing, right? The date time is stored in the file name. This is a awful, terrible thing to do. Don't ever do this. Don't ever try and store metadata in the file. Really try and stop thinking of your processing input and output as files. Instead, there's this paradigm of metadata in, metadata out, or stack in, stack out, where your workflow or your algorithm or your function takes in one or more stack items. And if it needs to download and access certain assets with that item, it can do that, but it's up to the algorithm. It's up to that workflow to decide to do that. And it can augment the metadata with additional metadata, or it can add an asset. Like let's say you had a workflow that was creating a cloud mask. You input a stack item, you create a cloud mask, you put that up in the cloud, and you add that asset, and you return that metadata file. The advantage here is that you can include some data provenance information, and you can include the fact that you ran this algorithm on here, including a version number. If you were creating a whole new stack item, like this was a level 1 to level 2 process, you can create a link using the relational type derived from to point back to that level 1 item. And it's just a really convenient way, I think, to think about how we process data is to operate on metadata first rather than data. Some challenges in Stack is, I guess the workflow thing wasn't the last, and I know I'm rapidly running out of time, but I said I was going to go over that. I was told I had time. But I do want to point out some challenges that have arisen in Stack over the last few years. One is just the sheer scale of metadata and the proliferation of data. We saw this in NASA CMR. NASA CMR is the metadata repository for NASA data, which started off much smaller, and now there's billions of granules in that. And we're seeing the same thing as more and more data is collected. And so that's been a challenge dealing with JSON. And so there's lots of talks this week about Stack GeoParquet and stuff, and so there's people working on ways around this. But that has been a challenge. The other thing is this idea that flexibility is the enemy of interoperability. In that Stack is super flexible, you can kind of do whatever you want, but it means that people, as I said, they don't often read the best practices, and they do things in different ways. And so in practice, we see that different Stack APIs, especially like maybe even mirrors of the same data sets that might be on different clouds, are done in different ways, and they're not completely interchangeable. And so that's a bit of a problem, along with the proliferation of extensions. There's also been this tendency, I think, to shoehorn problems and metadata into Stack, like putting a lot of stuff into Stack that maybe that's really not the right place for it. And using Stack for things like big giant vector databases, And again, a lot of these challenges I think have been identified, and people are working on various issues here. The interoperability across providers, well, I kind of alluded to that just now, but you look at Google, you look at AWS, you look at Microsoft, and there's the same data sets on all these clouds, and they're not the authoritative source in most cases. Like Landsat has the authoritative sources on AWS, but it's not on Google or Planetary Computer. And so this is a problem because there's not necessarily a way for a user to know that this data can be tracked back to an authoritative source if they're using the latest data or if it's been changed. And so that's a bit of a problem. And then I think the STAC governance via the steering committee was just an issue for a bit, and we've updated the steering committee because the original steering committee was, I feel like, pretty geographically isolated. It was all males. 4 of us were in North America, and we all worked for private companies except for one person. And so there really wasn't a whole lot of diversity in that steering committee, which I think was a problem. I mentioned STAC GeoParquet already. But we have a new steering committee now, and 6 of us are here out of the 7. Emmanuel is not here. So if you see any of us, really any of us would be happy to talk about STAC or just to say hello. And I want to also say that we have a community meeting. It's Mondays at 11 a.m. Eastern Time, and it alternates, so it's every other week. And there's a Google group, and you can sign up for that. And it's really, this isn't like to talk about the spec necessarily. It's to talk about whatever you want to talk about. If you're a user and you just want some help, or if you're using STAC and you want to talk to people, or if you're a provider and you have questions, join the community meeting, and it's a good way to get help. And that's it. Thank you. Are there
I
any
think we have time for 1 or 2 questions. Do we have questions? And then please wait, because we want to record also the questions, so you need a microphone. Okay, then I start here.
Hi, thank you. On the one of the last slide, I saw OGC API features versus STAC, and STAC is for cataloging and metadata, and there is OGC API records, and it's always confusing to me how to use STAC for features. Maybe it's going to be addressed in the next talk as well. So, could you tell something about that, please?
Like how to use STAC for features. Well, Chris alluded to a new project, and this morning he talked about, and so I think there will be a talk on it. But I actually do have this. Can I use STAC for vector data? And just quickly, STAC versus OGC API features. So we've got STAC items, right? And it's GeoJSON. The STAC vector defines where the data is, right? But the data is always in separate files. With OGC features, we're really defining regions of uniform properties, but we don't have any assets, right? There's no actual separate assets. And so my advice here is that if your geometry is in fact the data itself, use OGC features. But if your geometry is simply just a definition, if it's metadata defining where your data is located, then use STAC. But don't try and use STAC for something where the geometry is just the data. Does that answer your question?
And OGC records.
And OGC records, I don't have a great answer for that because OGC records came out after STAC, and so Chris might actually have a comment on that.
It's just trying to do a lot, I would say, with STAC features.
Okay, so I guess the answer is don't use it. One more question. I want to make sure Ben has time.
Firstly, thanks. This is super helpful for those like me who understand STAC on a high level but haven't done stuff in the weeds. This may be a dumb question, but others could be thinking it too. You talked a lot about extensions. I understand the implementations, kind of like metadata fields, but what exactly are extensions?
Yeah, so there's an awful lot of extensions. Should I look at all of these extensions? So, no, it's worked out really well though. Well, I planned if people didn't ask these questions, I was going to go through it, but I've run out of time. But no, the next several slides here do kind of go into all these different extensions, and it is super confusing. These slides will be available and you can look through it. But I think the bottom line to take away here is that the extensions are grouped by maturity. And so one way to look at these is focus your attention on just the stable or the candidate extensions. And I think this needs to be updated. And don't worry so much about like all the pilot extensions, unless it's something that really you think is really useful for you. Because those really don't have widespread adoption. But the stable ones are widely adopted, and you'll see those in a lot of different STAC APIs. So, okay.
Great. Thank you so much, Matt.
Oh, thank you. Thank you.